Normally, we do http4k talks, and they are usually about server-side development. They normally focus on the back end, things around testability, architecture, and so on. This talk is slightly different. Now we're going to talk about web development, and specific, some of the protocols that go well with HTTP that are powering the web, and potentially new trends of where web development is going. So my name is Ivan. I'm one of the co-creators of http4k. Been working with it for 8 years now. We just released version 6 with 180 modules, and we just passed 50 million downloads from Maven Central, which is quite a milestone for us. We don't have a booth this year, but if you want a sticker, just come and talk to me after the talk. I'm happy to provide some. I'm also part of Clockwork, which is a network of independent consultants specialized in continuous delivery. So we help teams get better at their pipelines, their testing strategies, trying to shift left and deliver quicker. And I was also part of the Google Developer Expert for Kotlin, but that's no longer a thing. If you want to learn more about why that is, also come and talk to me. So the plan for today is to talk about web development, how it looks like, and what are the new trends. But for that, I believe that we need to go back a bit in history and learn how we got to the place we are now. There were different approaches around history that made things better in some senses, made things worse in different ones, and it's good to learn about them and how they impact nowadays. And as I go through them, I'm going to explain how http4k supports those, and you can see how our philosophy matches with those approaches. And we're going to talk about the future, because I particularly believe web development is very complex nowadays, but I think there is hope. So hopefully I'm going to give something to think about. But before that, I want like a quick show of hands so I can get a feel for how long people been around and what have you seen in terms of web technology. So if I can get like, can you have your hands up if you used any of those browsers? Have you used Chrome or Edge? Okay, pretty much everyone has used one of those. I never use Edge. Don't miss it. What about Firefox or Safari? Yeah, like 70%. I still use Safari as my go-to browser, funnily enough. What about those? Opera or Internet Explorer? Okay, I'm getting a few like less hands now. Probably like 60% people have used one of those. If you had to maintain Internet Explorer, you know the pain it is. I'm sorry for your trauma. And what about those two? Netscape or Mosaic? Okay, very few hands already. There's probably less than 20% of people here have used those. So now, if you raise your hand, you're really showing your age. And finally, has anyone used any of those too? Okay, so now we're going to get people who really were there at the beginning and use Lynx, which is text-based, or use Nexus, which is the original web browser. Okay, so I can tell that people around Internet Explorer and forward came, so it gives me an idea. I think I'm going to show a few things that probably new to people here. But to use an example of what web development is nowadays, if you look at this screen that I'm showing here, simple list of users with some status and the last login, there's a lot of complexity that goes behind it that we take for granted. For instance, visually, you have things like drop shadows in the corner there. You have those round edges on the status. All those things are relatively new, 10 years or so, but new. Also, there's some expectations as a user nowadays that to get that list updated, for example, if the status of the user changes, you don't need to refresh that page. It will magically happen for you, and things will be dynamically updated. And these expectations mean that for the user, things are better, but it does mean we have to build a lot more things under the hood. So let's see how we could get to build such UI across history. So to start, In the 90s, when web development started, there was this thing called CGI. Does anyone know what CGI stands for? It's Common Gateway Interface. This is how original web servers start to allow dynamic content to be generated. What they would do is, if you get a particular request to a URL, sometimes those URLs with /CGI-bin, you will pass that to any program you had running on the server, and whatever response that program gave to you, it would return. So it will look a bit like this. You do a request to the server, it will establish a connection, and it will bring back some HTML. Very simple stuff. But if you make a second request, or you manually refresh the page, you can get different content, because that's powered by some real application behind the scenes. It's not just a static HTML. So this was very good in terms of allowing things to be dynamic. It's also very simple to test, because you can even just test the program. But in the 90s, if you want to have like information being updated automatically, the only option really you had was refreshing your browser, following a link, or submitting a form. And all of those operations would fully refresh the page, which means that at the time where you didn't have a lot of bandwidth, it would be a full page refresh, it would be slow, it would be inefficient. If you had a lot of information on the page, things would be slow. So that proved to be a challenge to increase the amount of information you can bring to the web. To implement something like that in http4k is simple. Probably if you work with Spring or Ktor or other framework, you have done things like that quite a lot. In http4k, we model this idea of getting a request, returning a response as a type alias. Simple as that. We call an HTTP handler. And to create that page for the user, all you have to do is define a data class, which is going to be your model. You choose a templating technology. In this case, we're using handlebars, but you can use Timeleaf, Pebble, whatever. We support all of those. And calling the templating renderer with that model will generate the HTML, and you can return that in the response. This gives you a server, effectively. This is your whole server code, but it works all in memory. It's just a function that will return some data classes. To make it work, you put it, you choose the kind of implementation you want to have for the real server. In this case, we're using Helidon, and you just get your function, do a server, and you start in a particular port. So this is enough to spin up a web server that can serve some dynamic content over time. Because what we define is just a function, testing is very easy. You just call the function. There's no mystery there. You don't need to have a mock request. You don't need to have like a fake server. You don't need to spin up a network. So this runs as quickly as calling any code you have. In this case, we just make a request and inspect the response. And you can inspect for anything you want. We're just looking at the OK, but you can look at much more. So what I've showed so far is still very limited in terms of making the web really dynamic and reactive is very limited. One thing that people tried to do late in the 90s, people discover that you could run a bit of JavaScript or using some meta tag, and you can do a first request. You're going to get some HTML for the list of users, and then you use some JavaScript to refresh automatically the page. And it will make the second request without the user having to interact. So this was the beginning of reactive, but not really, because all you're doing is fully refreshing the page. You still have all the challenges, and in some senses, you're making things even worse. When it comes to bandwidth and efficiency, you're potentially making it worse. When it comes to user experience, potentially make it really worse. Like if you have a big list of users, you're reading, and then halfway it starts refreshing without you asking, things even worse. But a few years later, Microsoft decided to create something as an ActiveX object in Internet Explorer, which would allow something revolutionary, which was I can just make a request from the page I'm on, get some data, and with some JavaScript, you can manipulate the DOM, and you can update that information in line. So that was the beginning of Ajax. Does anyone know what Ajax stands for? Asynchronous JavaScript and XML, which is really interesting because who has done any XML on the web nowadays? But at the time, JSON was not the standard that it is today. And people thought that really the servers would start returning XML and you use that data to power your website. And that was the beginning of single-page applications. The way it works is when you do your first request, you're going to get this initial HTML, and you're going to have some JavaScript that will tell what and when you want to load things. These JavaScript will use the XML HTTP request to make a request to the server, which will return. In this case, I'm showing an example already returning JSON, because no one does XML. And with that data, you can update. And you can keep making requests to the server, getting new data, and updating just that component. So this is the beginning of the web we know today, where you had specific components that could update in line based on user interaction. You will start getting a separation of data and presentation. And that's where JavaScript frameworks started to appear. I still remember when jQuery came about to make these things simple, just getting data and updating parts of the page. And that was incredible at the time. And in some senses, honestly, I think the web went a bit downhill from there in amount of complexity. But we'll see. We're going to talk about that. In http4k, to power a website like that, it's very similar to what we showed before. The only difference now is like you're probably going to have different kinds of routes. Some of them will return HTML and JavaScript, which we specify as static. And sometimes you want to have JSON. So you do users. And in that case, when you call JSON for a particular data class, it will serialize and bring the data back. Again, it's the same thing as a simple HTTP handler function. You can just mount that to any server, and off you go. But part of this shift around that time meant that now we're talking about exchange of data between the server, not necessarily HTML. And we want that data transfer to be efficient. And that's when we start talking about new protocols. So I'm going to do a slight detour and talk about the protocols, and then we can go back to the web discussion. And I want to talk about WebSockets. Who has used WebSocket here before? Just OK, probably more than half. So WebSockets came in 2011 with the promise of let's make the web truly dynamic and allow websites to have a two-way communication with the server. The way it works is that you make an initial request to the server, and when the server receives a specific request, knowing that's to initiate WebSocket, it will change the protocol, and then the communication becomes a general TCP protocol between the browser and the server. And that allows both sides to send information to each other and respond to it. So in this case, the client can make a request, send a frame to the server saying, give me the users, and the server can say, OK, here are the users. And you can have those interactions, which are no longer part of the browser page flow or part of an HTTP request. But you can keep the server. Now it creates an opportunity for the server to keep sending more data to the client. Yeah. So in http4k, because this protocol it works both ways, is slightly more complicated, but it still follows the same philosophy of being a simple function. When you request a WebSocket endpoint, you create a WebSocket consumer, which gives you the ability to send data, receive data, close, handle errors, and so on. And this is all done in memory in the same way as HTTP. And you can also mix and match WebSocket with your normal dynamic routes, with static routes, in the same way, using the poly handler. And following the same philosophy, even if you're serving WebSocket, when you create your application, what you're creating at the end of the day is just a function. The server is a function that you can just start. In this case, we're using Helidon again. And this is enough to serve a WebSocket that once you send a request for get users through the WebSocket, it will bring back that JSON that we showed earlier. And because it's simple as a function, we can easily create facilities to test that. We are not aware of any client that can be tested without spinning up something. But in http4k, those constructs are still in memory. You can see all the interactions between client and server. You can simulate them during test, like we do here. You create a WebSocket client, and you see, if I send a message, what do I get back, and so on. And you can check in the same way as any other data class. So if WebSocket looks so good on paper, why are we not using it? And the answer is that I think it came too late to the game. By the time we started using WebSocket, HTTP was very mature. And WebSocket would have to play catch up on things that we take for granted now, like caching, compression, the ability of having load balancing, and so on, observability. Everything is a bit more complicated. And in fact, if you've done stuff with WebSocket, you probably, especially if you've done WebSocket for the web, for the public, you see that it is flaky. It doesn't, like, you have to deal with a lot of edge cases for reconnection and so on, because it doesn't have all that built in out of the box. So that's why the adoption is not that prevalent as we expect. And I think that's also the reason that a few years later, people thought, like, can we do something that's not all the way full back and forth with the server? And that's where server-sent events came about. Who has used server-sent events from here? OK, a bit less than WebSocket. I'm surprised, because nowadays I would say server-sent events should be way more popular than it is. And I'm going to show later a bit why. So server-sent events is like, let's dial back a bit on WebSocket, and instead of creating a full-blown TCP protocol, let's do something that's work on top of existing HTTP infrastructure. The way it works is you make a request to the server, and you get a connection. You can make a separate request now. So this is the client talking to the server, saying, give me the users. And the server will basically keep that connection open, and the client will understand that that connection is open for the server to keep sending data. So notice that this is a one-direction thing of the server sending data to the client, because there's already a way for clients to send information to the server, to normal HTTP requests. That's the usual way we do it. But that allows the server to send new events when more data is available. So this was introduced back in 2015, and nowadays it's supported by all browsers anyway. In http4k, server-sent events is just a cut-down version of WebSockets, effectively. Follows the same design, where you create web SSC consumer every time you get a request, and with that request, you can just keep sending messages. So there's no way to receive data after that initial request, but you can keep sending more data to the client. Again, the routing follows the same philosophy. You can mix and match HTTP, normal HTTP with server-sent event, with WebSockets, with static. Doesn't really matter, which, especially in the case of server-sent events, is interesting, because since server-sent events is just HTTP, you can initially, in most cases, start with a normal route for an endpoint, and then add the reactivity of having server-sent events later. And again, you can start as a server just by mounting it to an existing backend. And in the same way as WebSocket, you can create a test, create a specific server-side event, server-sent event client that allow you to test things in memory. So this was our detour. So we look a bit into WebSocket and server-sent events. But what does that mean for web development? Right? We don't see, it's not, We don't see that everywhere, but let's see what we saw since we stopped. So around 10 years ago, there was a rediscovery that servers can render HTML. And at the time, I think already the amount of frameworks for JavaScript was getting a bit out of hand, and people saw websites getting bloated and slow. And one approach that people say, oh, we could generate HTML on the server, like we used to do 20 years before that. And that became the new trend for client-side for web development. So you have single-page applications, but they will render some of the HTML in the server and bring it back. So the way it works is the same way. You get some HTML and some JavaScript on the initial connection. You do XML requests, but this time, instead of getting data, you're going to get snippets of HTML that you can replace directly on your page. And you can repeat the request, get some other HTML, and do that. So you do have some benefits of now you can think a bit more into web components and things that the server renders this bit of the page, and you know how you compose them, and so on. But on the client, you still have a lot of the downsides. You still have to maintain a separate tech stack, a separate deployment strategy, a different platform. You have code still running on the server, and so on. And you have to deal with other things like the data hydration aspect, like do you have all the data that you wanted at the time you wanted, how is the initial state, and so on. Things are still very complex. So SPA is still a pain. Now, like, if you're doing web development nowadays, even if you're using React, doing things, if you want to do full stack development, especially if you're using Kotlin on the back end and JavaScript or TypeScript on the client, you're going to see that there is a lot of complexity involved on that. Apart from the build chain, the different technologies, there is a lot of complexity on the way you organize the application, the way you define the components, who is calling what, how do you choose what is the client-side logic, what's the server-side logic, and so on. How do you deal with security? If you have a separate API just to get data, now you're talking about security in two different ways. Like there's a lot of complexity there. But we have to talk about, is there any hope, any options? And we think there is. I left it out from the history here, but around the same time that there was Ajax, there was a competing standard that was fighting for it around the time that was just called asynchronous HTML over HTTP. It was AHA, so it's really hard to search for it. Like, you're hardly going to ever find content for that. But the idea was, let's just use Hypermedia. Instead of doing asynchronous JavaScript and XML, let's do asynchronous. We do HTTP and we get HTML, but we do that asynchronous. So that was something that this idea has almost 20 years, but it never caught on. But recently, some frameworks decided to pick those ideas, experiment with that, to try to solve some of the challenges we have with web development. And two of the most popular nowadays are HTMX and Datastar. The idea behind them is, instead of allowing people, expecting people to do front-end development by adding a lot of JavaScript in the browser, let's just provide a tiny bit of JavaScript to do a bit of glue, which they represent what we expect the browser should do, and just using HTML, you can define all the reactivity that you want. So I'm going to explain with a few examples for Datastar how that looks like. HTMX is not that different, but we believe that Datastar is a little bit better. So the workflow for a Datastar website is you start with some HTML, and you load the script, and you have that Datastar.js, which is 14K that you load, probably smaller than the icon for your website. And that will unlock some extra behavior that you can put straight in the attributes. So the important thing here, all the attributes that are data-something, they tell a bit about how the interaction between the client and the server should be. So in this case, what we're saying there is that when you start to load the list of users, I want you to load more data using the endpoint call /users. And I also want to store JSON information, just JavaScript object from the data endpoint when you click on that div. So there are two things here going on here. The first one is the idea of fragments. So what we told here is that the list of users will ask the server for some extra data. And the server can then return that data and tell the browser what to do with it. Not the data only, in this case, the whole HTML. So when you ask for /users, you bring a snippet of HTML, in that case, just the list itself with some users, and it's telling, just replace the list there with this information. There was no JavaScript written in the client for that. It's just the server returning some bit of information, and the framework knows how to pick it up and make it available. In the same way, if you click on that div, it goes to the server brings back some JSON, and the JSON will be replaced. That's for the cases where you still want to do some logic on the client, and for that you just want data. You don't want HTML. So the protocol here for Datastar is powered by server-sent events. Like I showed earlier, you ask for initial HTML. The HTML will have some special directives through attributes to say, I want to load more data. This is when and how I want to load that data. And that will tell the server what to do. It will do behind the scenes XML HTTP request, but this time it will be powered by server-sent events. So in this case, when you do a request to /users, it will expect some data to come back, including the instructions of what to do with that HTML fragment. So in this case, we bring back the list of users, and we say we want to merge those fragments, and it will know that it's to replace that list. You have different operations. The server can tell, I don't want you to replace. I want you to append. I want you to put before. I want to put after. I want you to put outside, inside. Doesn't matter. This is all controlled by the server at this point. And it can keep pushing new fragments. So if you want to update the whole list, if the list is growing, you can just send new elements, or you can send the whole list. It's up to the server to decide. The same principle is followed with the data stream. So if you have a signal that you want more information about the users, you can just send that data directly through JSON. So this gives very basic primitives for HTML that you can use to build your website and have all the reactivity that you expect without having to write anything on the client, basically. We're moving the logic back to the server, who's going to be responsible for rendering the HTML and tell, when you give parts of the of your page, what to do with it. So how does that look in http4k? Because we already have support for SSE, we already have ability to render things, we already have the routing. Datastar is just a simple abstraction layer on top of these existing components. So for the rendering part, we just have a special Datastar fragment renderer that you can plug on top of any renderer you want. If you want to use, again, Pebble, Timeleaf, doesn't matter. You can give that HTML back through for a Datastar website with no problem. And in SSE, you tell, instead of just sending the message back, you can choose to send a Datastar merge fragment. And that not only has the HTML, but on that point, you can give instructions to the client about what to do with HTML. So when you have sse.send merge fragments, you can tell, and just append this after my component, for example. Yeah. But the main shift here is that we try as much as possible to remove all the complexity from the browser here, and we go back to the server telling how to behave. And we think this is a beacon of sanity on web development. We've been trying recently, and the amount of complexity that you can get rid of by trying this approach is massive. It does require people who want to do server-side development, and there is like a social challenge that I didn't go through the history, but when we started shifting JavaScript for the client and whatever language for the server, effectively our industry created two specializations for server-side and front-end. Datastar will challenge that a bit, because in theory now you are producing your HTML on the server closer to the data. But it does bring a lot of advantages. Like we mentioned earlier, we do want things to be reactive. We want things to be efficient. But if we also want to have a simpler build stack infrastructure, less complexity, less tech stacks, Datastar and all these frameworks will give you that. Now I'm going to show a couple of demos of how Datastar can behave in practice. So those use HTTP, Datastar, we are serving them in Helidon, and they are all powered by virtual threads behind the scene. So the first demo is that website that we mentioned earlier, a list of users, which, as you can see, every second or so, he updates the status. And all he's doing, in this case with Datastar, you can see the Datastar merge fragments. All we're doing is bringing a different information for the user, and is updated in line. There's we didn't write any JavaScript for that. It's basically server-sent events telling how to update the UI. So this is an example of the merge fragments giving back some HTML for the client. The second example is using the signals. So this case, we're going to do something that's a bit like streaming. And it follows the same approach. You have something that looks like is an ASCII video. And all it's doing, every frame you see there, is just an array of strings with inside JSON. And all the client is doing is getting that data and displaying in a HTML element. So this code, there's more code related to taking the data from a zip file, which is actually the source for this, than the actual serving, because the routing and so on is extremely simple to do a website like this. And again, there's no code on the client to make that happen. And we think that this is already ready for the prime time. We want to see more websites using Datastar. We know various frameworks support server-sent events, so it's easy to integrate with them. Helidon, Undertow, Jetty. And Datastar will work with any of those out of the box if you're using http4k. And to summarize, I think it's interesting to see the history repeating itself. In the same way that SPA websites, they rediscovered that you could generate HTML on the server. Now we are rediscovering that you can ask the browser to do more things as a standard and just move more the logic to the server as well. And you can do a lot of this with very little. In this case, just 14K of JavaScript on your browser. So the summary also, we'd like to include a little plug for http4k. If you haven't used yet, like I mentioned, we released version 6 back in February. We passed 15 million downloads from Maven Central. And we're including now some pro modules, including MCP, for example. And we noticed that some teams want to start playing with http4k in their existing projects. So we created bridge modules that allow people to, if you're using Spring, for example, you can just create a root integrate with http4k, and see how it goes. We don't want people to have a big bang migration. You can try. If you like, you can incrementally change, or if you don't like, you can incrementally remove it. It's your choice. But we wanted to give this choice, and we did for various existing frameworks, including Micronaut, Vertex, and so on. And that was it for today. Thank you very much. I put the link to the code if you want to check it out, those demos, they are there. We do have time for a few questions. If people want to ask questions, you have to come to one of the microphones, I think. Otherwise, thank you again. Cool.
I have one question. It would be like, if you are using something like that with server-sent events and everything, how do the server know how to send the message to the browser?
How the server knows how to send or when to send?
How to send. How to send.
Well, there are various ways. For a simple example is if you have a server that is connected to some queue or event coming from a different server, you can connect what you have in the browser. You have someone on that page waiting for new information. You get stuff from the queue and pop to the user there. Usually, that's the kind of pattern we're going to see, that you create, you establish this connection to the server, and then you're going to have to start listening to events from other parts of your backend. And when you get those events, they will translate into sending more data to the client, whatever is relevant in that context. Does that make sense?
Oh, yes. Thank you very much.
Thank you.
Hello. So with our team, we are using the HTMX. It looks similar to the Datastar.
Yep.
And we feel that somehow we hit limit in case of like client-side interactivity. I mean, I would say that some state is only on client-side. Okay. Like not everything is persistent database, not everything is server. Yep. And then wondering, are there some mechanisms to use in Datastar to handle like DOM content dynamically? So I mean like user do some interaction, and we can dynamically generate HTML on client side to have like, let's say, React-like experience, but with this tool. So
let me see if I understood the question. It's like, is the difference between HTMX and Datastar when it comes to like where you keep the logic?
Yeah, like I mainly think about like, let's say we have a list where a user can add the rows. So it's not like state to keep on server side, but on client side. So I'm thinking how to build this UI, because we can write like, I guess, plain JavaScript, but I think it's not scalable too much. So I'm wondering if there are some tools in Datastar to use for this kind of problems.
Datastar, from my understanding, especially the Datastar, if you go to their Slack, they kind of have a challenge of give me a behavior that you want to see in the client that we don't support. So I would say, like, if you have a specific example, the best way to try is on their Slack and say, I don't find a way to do this kind of reactivity without putting some code in the client. Is it possible? They kind of have a challenge at the moment. They claim that most of, like, all the patterns that we see out there on the web now are possible.
Okay. Thanks.
Hi. Thanks for the talk. One thing I noticed that touches a little bit on what they were talking about, I think. In your talk, you mentioned how it's a desirable thing or a beneficial thing to have the server managing state for all the clients.
Yeah.
Isn't that a matter of philosophy, though? Because data centers are becoming more and more demanding and requiring more energy. People's computers and phones are becoming more powerful, have cycles to spare. The alternative approach is basically have them download an application effectively and just offer an API on the server side. And then also maybe use more efficient protocols than just HTTP.
Yes, I think this doesn't solve the trade-off between native apps or the web. I think like you still have to make a choice here, and you're right. Like it may be depending on the kind of dynamic behavior you want to have for a particular, very personalized user experience, and a native app makes more sense.
Yeah, or a more complex JavaScript application, effectively.
Yeah, if you want to have a more complex interaction, like the kind of animation things that can only be done on the client, HTMX won't solve for that. But in my experience, I would say 95%, 99% of the websites are just tables and lists and forms. That's all that is. And we keep adding complexity to just do tables and lists and forms. And this is an attempt to make that part more simple.
OK, thank you.
Welcome.
Yeah, so I have a question regarding the server-sent events support.
Yep.
Because I tried using it with Spring around 2 to 3 years ago, and I remember that I had issues with detecting when the connection closes. Yeah, when I was researching this topic, it was written on Stack Overflow or something like that, that there is need to send some data in constant interval time to detect that detection closes, and I remember that yeah, it was problematic. And yeah. I'd like to ask, does http4k solve this issue somehow?
So, like I mentioned, in http4k, we deal with the abstractions on top of existing server, existing infrastructure. There are many things that can make SSE or any protocol break, including what your proxies are doing, your load balancers are doing, and so on. I didn't get into the details, but server-sent events, they deal with reconnections with the browser. You can configure in the browser a retry time, which if things fail, it will try it again. But it's up to the real server implementation about how they serve the content and how they close the connection, basically. So http4k itself won't manage the connection for you. But we do expect between the browsers and these layers, for example, if you use Helidon, you're going to have to rely on like what Helidon and whatever infrastructure where you deploy. Server-sent events is still, it depends on, like I said, there's load balancing, there's like how you keep connections depending on the proxies you have on the way to the internet. Behavior may change. Yeah.
Okay, thank you.
You're welcome.
Hi, I have a question about how threads play a role here. Like,
what? Sorry.
Like virtual threads.
Yeah.
Do you keep one for each user, or
Yes.
maybe one for each fragment that might get updated by the backend?
So in the examples, you can see what we do is we start a new virtual thread for each server-sent event connection, basically. Simple as that.
So if you have a complex application where multiple parts might require a backend event,
Yeah.
it's still one thread by user.
Again, we're leveraging the fact that those should be cheap now and doing that.
Okay, cool. Thanks.
Cool. I think we're done. Thank you.